Good morning, judges. We are Team Physics presenting our RoboCup OnStage presentation. We are 𝗍𝙗𝗀, the team leader in software, 𝗘𝗱𝘂𝗪𝗍𝗂 𝗔𝙠𝙗𝗃 𝗢𝗏 and 𝗍𝙗𝗃 𝗔𝙤𝙗𝗃.
Now, let's take a look at our robot and its technical capabilities. Here are photos from all 6 sides of the robot. Next, here is the isometric view of the robot. Our robot mainly consists of 4 sections: the claw, the 𝗍𝗍, the base structure, and the omni wheels. There are 2 main mechanisms that were built for this robot. Firstly, we have the claw mechanism. A marker will be held in the yellow part of the claw. There are also red rubber parts and rubber bands on the yellow part of the claw. This is to increase the friction between the claw and the marker so that the marker doesn't fall or fly out during a performance, keeping it stable. The body of the claw is also rhombus in shape. This allows for the marker to move and draw a 180 degrees curve and straight lines from multiple directions. Another mechanism that we use to build our robot are omni wheels. Instead of using regular wheels, we decided to use omni wheels for various reasons. We structured our base so that the 4 omni wheels were attached in a square formation. This allows the robot to move in every direction without having to rotate the whole robot at a specific angle. This allows the robot to have a higher efficiency of movement. It also decreases the time it takes to move from one point to another, thus saving time. When the robot uses omni wheels rather than normal wheels, the drawings and lines from the marker will also be more exact, as the robot will not need to lift up the marker, rotate, and place back the marker on the same specific point, causing cleaner drawings and decreasing the inaccuracy of the robot.
Now, let's move on to our performance concepts. The main plot of our performance is 2 robots with different styles meet and can't decide on who draws better. The design for both robots are the same, but the way each of them draw is different. The robots draw by moving their claws where a marker will be attached. Different patterns in design will be drawn by the robots, using the claw and the omni wheels. And the shapes that can be drawn are the basic elements of editing, using curves and lines.
Let's move on to the software section. Neurostyle transfer is a technique that allows you to combine the style of one image with the content of another image, resulting in a new image that looks like a combination of the two. Pause here to see the flow of the process. 𝗍𝗍𝗪 is a type of pre-trained neural network that is used in machine learning and computer vision. Think of it like a really fancy filter that has already been trained on millions of images and is good at recognizing different patterns and features within those images. I use 𝗍𝗍𝗪 to extract different features from the input image at different levels of abstraction. For example, 𝗍𝗍𝗪 has many layers, and the earlier layers detect simple features like edges and curves, while later layers detect more complex features like shapes and objects. It extracts all of these different features. The gram matrix is used to quantify the style of an image. Essentially, it takes the features that are extracted from an image and calculates the relationships between them. This is important because the gram matrix can capture the overall texture and patterns of an image rather than just the individual features. By comparing the gram matrix of the style image to the generated image, it can calculate how well the generated image matches the overall style of the style image. The loss function is a measure of how well the generated image matches the desired output. Gradient descent is a mathematical optimization algorithm used to minimize the loss function by finding the lowest point or local minimum of that function. The lowest point is the desired output. To put it simply, gradient descent is a way to find the best values for the pixels in the generated image, then minimize the loss function and make it look as much like the desired output as possible. Here is a visualization of it.
And now, I'll be talking about the challenges we faced and how we overcame them. Firstly, this was the first time competing in this competition for all of our team members. So, we asked our seniors and CCA mates who had participated in this competition before for advice and help when we needed it. Another challenge we faced was that we had to rebuild our robot because we had to change our 𝗍𝗍 brain. The new 𝗍𝗍 brain was a lot smaller and we had not used it before. There were also less parts overall. We asked our coach for help and we didn't give up. When we changed our 𝗍𝗍, we tried to think optimistically, and so we thought it was a good opportunity to improve and revise our old design and try to fix any mistakes to make our robot more stable. Here are the before and after pics of our robot. On the left is with the old 𝗍𝗍. It was too bulky and was too heavy on one side, so the center of gravity was very off. There also wasn't enough ports for the motors as we had 6 and there were only 4 motor ports. On the right is with the new 𝗍𝗍. The new 𝗍𝗍 is a lot smaller. So the center of gravity is a lot more even and the robot was more stable. The new 𝗍𝗍 has a total of 6 ports that can be used for the 6 motors that we are using. Here is the last problem we faced, which was that since the COVID-19 measures were easing, there were a lot more activities and events that we had to take part in this year compared to the years before. So we really shared free time, especially since we had classes outside of school too. We made a shared calendar on Google Spreadsheet to indicate important dates for this competition and also when we were free to meet. We also worked asynchronously for some parts of the robot. We also made full use of the time we had during CCA sessions. This was so that we could manage and spend our time wisely. The picture below shows the shared calendar we made on Google Spreadsheets. Thank you!